Hello, folks. I am just going to go over the final exam, and let's get started on the final exam. Let me do a quick sound check. It looks like I am good. So, this is your final exam, and this is kind of an overview of the course. It's a quick rundown, and here's the data. We'll go over the questions before we go over the data. So, alright. So, first, you need to recode this. Well, first, you're a social worker and you're interested in child abuse and neglect. So, what you're doing today is you're trying to figure out what predicts reasons for foster placement. So, the reason for foster placement, okay, it would mean that's your dependent variable. So, you need to find the predictor variables for two reasons. Either it'll be physically violent, neglect case, sex abuse, runaway, out of control behavior. You need to choose two of these, okay? So you need to choose two. You observe the data included. So first, you want to recode the data. Well, let's take a look at the data. Here's the data, as you can see. Let's close this. It's a bunch of stuff that we don't really need. We'll enable an editing. Alright, so here we have with the nice data set. This data set has your child ID. We have a sample of 100. It's got the age of every child, sex, race, location, a wealth index. That's an ordinal coding. We'll get to that when we get to that. The reason for foster placement. So these are the reasons for foster placement. As you can see, there's 5. And we get to see each kid's story. So does this kid have previous juvenile delinquents? Yes. Previous home alcoholism? Yes. Previous home domestic violence? Yes. This kid's had a rough life. Previous single parent home? Were they in a single parent household? Yes. Previous sex abuse? No, they have not been sexually abused. This person has been physically abused, and this person has not gone through any neglect. And this is just child 1. So child 1 comes from a home that has alcoholism, has domestic violence, so on and so forth. Let's check out child 20. Child 20 is a 16-year-old black female from Portland area of Louisville. Their household is a wealth ranking of 2, which is poverty, honestly. So this child has had previous juvenile delinquency, previous home alcoholism, previous domestic violence in the home, does not come from a single parent household, has been sexually abused, has been physically abused, and has endured neglect. That is child 20. Child 30. Child 30, 16-year-old female from Oklahoma, white, sex abuse was the reason for foster placement. This child has had previous juvenile delinquency, previous home alcoholism, previous home domestic violence, previous single parent household. This child is complete yeses across the board. So as you can see, that's these 100 children. They all have their own stories. So make sure you observe them. So the first part of the assignment is to recode the data. So you have a categorical data set and a numeric data set. Now what do I mean when I say code it so you have two different data sets? Well, I want you to make sure these are all into categories and numerics. Okay, as you can see, a lot of this is just category already. Frankly, most of it's category. So let's just go ahead and click the little triangle here, and then right-click, copy the entire thing. We're just gonna make a new tab. We're gonna call it data 2 or whatever you want to call it. We're gonna paste it. So now we have two different data sets. What I want you to do is I want you to make one of your data sets categories. Now remember, these are IDs, so they don't really count for anything. IDs are just IDs. So we need to code age into a category, and we need to code the poverty index into a category. So let's go to our code book real quick. Now we'll say age category equal. Let's go ahead and calculate our range real quick. So equal minimum enter. Our youngest kid is 11 years old, and our oldest kid is 18 years old. Let's find this 11-year-old. Where's this 11-year-old in this data set? Oh, we'll do it. There it is. I can already see it. We got an 11-year-old male. So this is our min max, which means our categories are going to be between the ages of 11 and 18. So let's go ahead and category this out in our code book. So we'll say preteen equal 10 through 12. Okay. We'll go with younger teen equal 13 through 15, and then 13. I did say 13, just typoed that 12. 13 through 15, and we'll say older teen equal 16 through 18. I believe was the maximum value. Yep. Alright. So now that we have that, we'll rename this data category data. And we're just going to replace, anything that's 12. Let's go to our code book. We'll say preteen. So remember 10 through 12 is preteen. Even though we don't have any 10-year-olds in the data set. It was just in there just to make sure, we got down to the very bottom. So we're just going to look for all the preteens. Well, what we're going to actually do is I'm going to undo that, and we're going to do this the fast way. This set comes pre-filtered. As you can see, there's already filters. But if you do need to filter it, there's a little button here. You highlight the entire row up here. And there's going to be a little filter. It says sort and filter. You can filter it there. See, it turns it off. But we want it on. And what you can do with this filter is you can click the arrow here, and you can say sort from smallest to largest. And you can get all of them sorted. Real nice. So what we're going to do here, type in preteen right here. Copy. And we're just going to paste everything down to the 12-year-old. Easy peasy. And then we'll say younger teen. And copy this all the way down to, I believe, we said 15. So everything to the 15. And there we go. And then we have our older teen. I believe that's what we called it. Yep. And we're just going to, everything else is an older teen. Very good. Alright, now you see that changed our values down to 0, but that doesn't matter for now. This is just our category data. Next, we need to go to the wealth index. And we'll do a quick min and max on this. I believe it's 1 and 5. Kind of lifted my finger too quick there. Yep, 1 through 5. So we'll go to our code book. And we're going to go categories for wealth. Equal. And we'll go 1 through 2 will be working class. 3 through 4 will be middle class. And you don't have to specifically, call it anything. It's just whatever your definition is. And 5 can be upper class. So let's go ahead and do the same thing here. We're now going to go to previous home index, and we're just going to sort from smallest to largest. Working class. Paste this out. Down and get all the 2s. middle class. Let's go ahead and make sure all your things are at match case, because sometimes things get case sensitive. Capture all the 4s, and then finally upper class, which it's not too many. I keep on accidentally not uppercasing the C there. There we go. So this now these are all words. So that is your categorical data set. Now for our second data, we need to code these into numeric or interval ratio. So how do you do this? Well, first things first, let's rename this to interval ratio or numeric or whatever you want to call it. And let's just do this real quick, okay? See all these yes, no's? These are easy 0, 1s. So highlight everything. Hit a Control F. We're just going to do a find and replace real quick. Find yes. And replace with 1. Replace all. Remember, this is Control plus F, what I just did. And then you find your no's. And hit 0. Replace all. And there you go. And look at that. All numbers. Now we're going to categorize all this stuff right here. Let's go ahead and filter this again. Let's take a look at how many categories we have. We got 1, 2, 3, 4, 5. We got 5 categories. So let's go to our code book and we'll say previous juvenile delinquents. We'll code this out. We'll say numeric no equal 0, yes equal 1. And these are, but you can do it both ways. 16 to 18 older teen, or older teen equals 16 to 18. They mean the same thing, so you don't have to worry about too much about that. And then we're just gonna copy paste this all over here. The reason for false replacement, what you're going to do is you're going to do the same thing, and you're just going to work your physically violent. 1 equal physically violent, and you want to keep doing that all the way down. 2 equal the next category, 3 equal the next category, and so on and so forth. You will have 5 categories here. Area of the city, the same deal. Okay. Race, same deal. You're going to take a look at white, black. You remember to look at your filter. We got 4 categories of race. We got 2 categories of sex, and of course you can just copy. This is already numeric, so you don't have to worry about it. So there you go. That's how you do question 1. Question 2: with the data provided, construct 2 crosstabs using the categorical data, and then do chi-square for both your crosstab tables. I'll do one real quick for you. So let's go to our category data, because remember that's what you need for crosstab. Highlight the entire thing, insert, pivot table from range, hit OK. Remember our ID goes in there, and we change our value default settings to count. So we have 100 kids. Now, remember what we're asking for here, okay? We're asking for what predicts foster placement, okay? That's our job. And we need to find 2 predictors, so 2 tables. Coincidentally, I'm asking for 2 crosstabs. So let's go to our cross tables, our pivot tables. And previous reason for Foster placement, we're just going to grab this, and that'll be our rows. Okay. Now, our column, we'll do whatever predicted rows. So let's take a look at single parent household. And here is one table. Okay. Let's go ahead and paste this out. Paste special values. Next, let's just change this up. And let's go with home alcoholism. You can do any of these. Anything that you're curious about. And we can copy this again. Oops, didn't mean to hit that. Keep on hitting the shortcut for paste, and it's not what I need to do. You need to paste special values. And go ahead and calculate chi-square and do the whole, refer to the chi-square video if you need help with that process. But, you know, it's the same deal. We can, for your own sanity, just remove this blank row and extend that out. So just remember, it is. Just gonna remove this blank row. We're gonna go ahead and get rid of this pivot table. Oh my goodness, stop. Just gonna get this out of the way. Alright. I'm gonna delete that. Delete that blank one too. We're just going to copy this over, make our second one. Remember, for chi-square, we need two tables. And we need to know, so now we can just, you know, our expected, we'll say actual, here are our actuals. And this is our alt hypothesis. And then here is the expected or null hypothesis. So for null, remember, it's all things should be equal. Not really all things equal. It's just like, you know, we're controlling for everything here. So it's the same deal where we go equal the row times the column divided by the grand total. And just keep doing that all the way down until you fill out all the cells. Again, your row times your column divided by the grand total. This is, you know, same deal down here. It's just row times column divided by grand total. You know, that doesn't change. And notice, like, you know, these are very different values. Now, this is going to be very telling. I'm just going to go ahead and do, you know, one. Put those dollar signs in there for to lock in the R. And we're going to double dollar signs the grand total. And what this does is it saves us a lot of time. So now I can just, you know, go over like so, but, you know, we're going to actually remove, we're going to unlock the column and hold Q constant instead. Hold, hold on, I have a bit of a brain freeze here. Q constant. So there we go. Hold Q constant with a $. See how that looks out. Let's drag this down. And I did it wrong, of course, because, oops, let's see. It's late. So the row is correct, and the, oh, I see the problem. I need to hold the 10 constant, Q10, because it doesn't change. So I need to hold everything constant. And now we drag it down. There we go. Make sure everything's right here. That's not right. We're just going to go back to 10. There we go. See, it's row times column divided by grand total. We're going to do the same thing over here. We're going to, move our rows, so the R5. We're going to delete that $sign there. We're going to hold the whole cell over here constant, so double $signs. Lock the P and lock the 10. Drag it down. And that produces, yes, same numbers. And then we're going to calculate our p-value. So equal chi-test. Highlight everything but the totals. It's actually asking for the actual, which is your alt. And then it's going to ask for expected, so everything but the totals. Enter. And you're going to get this really, really small number. I wonder if I stretch it out, will it show in non-scientific? It won't. But anyway, remember a scientific number 1.42211 e to the negative 0.8 place is we're going to take this number 1.42211 and we're going to move this decimal about 8 times over this way. Now, as you would figure, so that's one place, place it there. 2 place, 3 place, 4 place, 5 place, 6 place, 7 place, 8 place. So, yep. So that's what that looks like. And you see Excel just converted it over to a scientific notation, but that's what the number actually looks like. And that's a very tiny number, which means, oh crap, our hypothesis is true. In other words, you can see here, our first pivot table, which I believe was previous home alcoholism. No, it was single-parent households. Single-parent households do, in fact, impact whether a kid's going to be these things. Be previous. You can see if it's in a single-parent household, it would mean the kid has an increased chance of being neglected, an increased chance to have out-of-control behavior, increased chance to be physically violent, and so on and so forth. So, and then you need to do the same thing down here to test that hypothesis right here. And remember, you're testing whether or not foster placement is impacted by your independent variables, your 2 independent variables, which will be either physically violent, neglect, sex abuse, runaway, out of control behavior. Choose 2 of them. So, just keep that in mind. I left out the single parent household there, but I might have added that. But anyway, well, so there you go. Hopefully that's clear. You're just seeing if these things impact these things. You could also see other things too, if you wanted to. You could go over here and check out the, age, sex, and race all that deal if you really wanted to. But that's your chi-square. With the data sheet provided, apply the filter function to the variables. Report your stats for 5 variables that are split between male and female. So how do you do this one? Well, let's go back to our category data, our interval ratio data. Okay. Now you will have these coded in the numbers. So we're going to make 2 copies again. So make 2 blank tabs. And we're going to call this male. We're going to call this female. And we're going to filter this little check mark here. So click your filter and only show the boys. And then we're just going to highlight the whole thing. Now notice that it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and it skips to 14. That's because it's only hiding the girls right here. So we need to copy it and go to the boys tab, paste special, and values only. This will successfully create a boy only data set. And then you do the same thing for the girls. Go to your filter again. Show only girls. And then copy. If you're wondering what those lines are, that's where the data set, hides the boys in this case. Paste values only. And there you go. Now you have your data set. Now, again, these will all be on numbers because you've already coded them. And then what you would do here is you just, equal average. Highlight this. Equal median. So on and so forth. So remember your descriptives are your mean, your median, your mode, your your min, your max, so on and so forth. Finally, with the data provided, construct correlation table. Show your R for at least 5 relationships. Now, for correlations, you need interval ratio data only. You don't want any categorical data in there. So just construct your correlations with this data set only, with your interval ratio. Refer to correlations for help on that. And then finally, summarize all your findings as if you were handing this to a stakeholder. Report your correlations, what seems to cause foster placement, and if the project warrants further investigation. Project would warrant further investigation if things came back significant. Okay, that's what I mean by use chi-square to justify if the findings were proper or not, your p-values. And then once you do that, just do a write-up on it, and then that's it. So hopefully that helps with the assignment. And I will, of course, if you need any help, email me. We can schedule a meeting, and we can walk through it in person. It doesn't bother me. So, all right. Good luck.